Hello everyone, today we're going to talk about oxidation numbers. Now an oxidation number is what you'd get if you assigned all the electrons in a bond to the most electronegative atom. Now this is not the same as formal charge. Not the same. For formal charge, you use that when making Lewis structures. Oxidation numbers you use for redox reactions, which you'll learn in class shortly after learning about this. Now in class, you're told that oxygen usually has a redox or an oxidation number of -2, hydrogen usually has one of +1, and so on and so forth. I want to take a second and kind of show you where this comes from. Now the oxidation number, the formula for it, is group number minus valence electron assignment. And valence electron assignment basically just means electrons around an atom. So let's take a look at oxygen here, something that is very electronegative. It has a group number of 6. If you count over 1, 2, 3, 4, 5, 6, and we don't count the transition metals. So it has a group number of 6. And let's count the valence electron assignments. We have 1, 2, 3, 4 from the lone pairs. And in each bond, there is 2 electrons. And here we have 2 bonds. And all of those electrons are going to go to oxygen because it is the most electronegative. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So 6 minus 8, that equals -2. And that's how we normally get a -2 oxidation number for oxygen. So there are exceptions. And let's do the same for hydrogen. Hydrogen has a group number of 1. And there are 2 electrons in this bond, but all of them are going to go to oxygen. Hydrogen's not very electronegative relative to oxygen. So it's going to be 1 minus 0, and that gives you 1. And that's how we get the oxidation number of +1. Now, I want you to take a second and try to do the same for arsenic. Pause the video if you need to, and go ahead. Now, arsenic has a group number of 5. 1, 2, 3, 4, 5. And it is surrounded by oxygens that it's bonded to. I want you to count the electrons in each bond. 2, 4, 6, 8, 10. All of those are going to go to oxygen. So 5 minus 0 equals an oxidation number of 5, or +5. Now for oxidation numbers, if you add up all of them together, you should get the original charge of the overall molecule. Now let's take a look here. We have a +5 from arsenic. We have 1, 2, 3, 4 oxygens that have a -2 charge, so that's going to be 4 times -2, and we're going to have 1, 2, 3 hydrogens that have a +1. It's going to be 3 times 1. And I'll erase the little plus sign by 5 so you don't get confused. Now if we add all of this together, we should get 0, since the original molecule had an overall charge of 0. And that's going to be the same as 8 minus -8. 8 minus 8 equals 0, and that matches up with what we were originally told. Now drawing the Lewis structures is a good way to get a general idea of what's happening, but there's some things you can't always do that with, and that is going to be seen with our next example. If you think you can get it, I want you to pause the video and go ahead and try it. Now in class we're told that for this, fluorine usually has an oxidation number of -1. We have 2 -1s, so that's going to be 2 times -1. We don't know what the oxidation number is for tin. We do not know that, so we're just going to call tin X. just like we were back in algebra. And all of that should add up to 0, since the overall charge on this is 0. So 2 times -1, that is going to be the same as -2 plus x equals 0. To get x alone, you add 2 to both sides. So it's going to be plus 2 and plus 2. Over here, the 2's cancel. And that leaves you with x equals positive 2. And that is going to be the oxidation number for tin. And if you add it up, -2 plus positive 2 equals 0. That's the same charge as the overall molecule that we started with. Now, again, I encourage you to pause the video and try the next one on your own. Here, we do not know the group number for platinum. That's not something that we know since it's in the transition metals. So we're going to have to figure out by doing the algebra way. We know that chlorine usually has an oxidation number of -1. So we have 6 chlorines, and those are each going to have a -1 charge. Now before, we always did this equal to 0, but here we can see that the overall molecule has a -1 charge. So that is going to have to equal -1. We have 1 platinum, so that's going to be x plus 6 times -1 equals -1. That's going to be the same as 6, or x minus 6 equals -1. To get rid of the 6 and isolate x, you add 6 to each side. The 6's over here cancel, and you wind up with x equals positive 5. Now if you add that back up, 5 minus 6 equals -1. That is the same charge that we originally started with. And that is how you find oxidation numbers for various atoms.